prove itself either effective or completely useless right there on the job in the midst of a fire. There is no way of testing it or trying it out in advance. And this is life-saving equipment we are talking about. Take the analogy of a car. You drive it every day, and obviously for your own safety, you regularly check your brakes. But with an extinguisher, there is no way of knowing if the brakes are working until you actually use it. Now, portable extinguishers are great weapons of first attack against fire, but only if the equipment has been well designed and well maintained, and only if the user is prepared and well trained. These two are the key. First, well designed and well maintained extinguishers, and second, a user who is properly trained, fully informed and well prepared. Product, maintenance and training. Exactly what Ceasefire Integrated Services is all about. Now, over the years, our team at Ceasefire has worked closely with independent testing facilities to study the way fires start and spread, and also the ways in which fire extinguishers can be best built to fight these.
The best teacher of fire safety is in fact fire itself, for it is only through studying the characteristics of fire that we learn the rules of fire safety and the features that make up an ideal fire extinguisher. This is a simple representation of how fires happen. For any fire to start and sustain itself, there are three elements that must be present: fuel, oxygen and heat. All extinguishers work by cutting off one or more of these three elements. First, we're going to look at the speed with which fire grows in power and spreads over more and more area. Watch the digital timer at the bottom right corner. See how in just a few minutes this fire spreads from the sofa to the entire room. At the same time, it is growing in intensity from a small blaze of about 200 degrees Celsius to 1000 degrees Celsius inferno. Finally, we get to the point where everything in the room catches fire simultaneously. This is flashover. Remember, all this happened in less than 5 minutes. We call this phenomenon the speed-power equation. The speed-power equation is simply a combination of A, speed, which is how fast a fire spreads from one point outward, and B, power, which is how powerful that fire is at that point of time. Now, the interesting thing about it is that the speed-power equation grows not in a linear manner as we would expect, but rather exponentially. So this flame, for instance, doesn't grow from 1 to 2 to 3 in terms of power and spread, but instead jumps from 2 to 4 to 16 to 256 and so on. In short, a fire which doubles in the first minute, quadruples in the next and grows tenfold in the next. There are two stages of fire: the critical stage and the blaze stage. Once the fire has reached the blaze stage, it becomes almost impossible to put out with fire extinguishers. So, it is only during the critical stage, which lasts anywhere from 3 to 7 minutes, depending on the fuel that's burning, when the fire can actually be fought with a fire extinguisher. And even within the critical stage, you need ever-increasing amounts of firefighting power as the fire grows. So, if you were fighting a fire at this point, you would need a certain amount of firefighting power. But if you were fighting it here, you would need 4x. And if you were fighting it here, you would need 10x firefighting power. In fact, after a particular point, you would not be able to fight the fire at all, no matter how big or powerful your extinguisher. This geometric spread of fire occurs through three processes: convection, radiation and conduction.
Convection is the transfer of heat by the actual movement of the warmed matter. So, for example, heat moves outwards from a burning object as the currents of smoke and hot air rise. Conduction is the transfer and distribution of heat energy from atom to atom within a substance. For example, a burning chair gets hotter and hotter because the heat from the burning area is conducted along the rest of the wood. Radiation involves the transportation of heat and heat energy through empty space or a vacuum. A good example of this is when a flame from one end of a burning room leaps across to the other end through thin air.
These are the very processes that cause the fire to apparently jump across distances during the blaze stage, as combustible materials some distance away from the fire heat up to the point where they ignite on their own. All of these factors bring us to one critical conclusion: that it is of utmost importance to attack a fire as soon as possible and with as much firefighting power as possible. And from there, we can move one step further to say that a fire extinguisher must therefore be light and portable, fast to activate and simple to use and very powerful. To illustrate the need for portability, fast activation and easy operation, let's say you discovered the fire at this stage. You would need to locate the extinguisher, unhook it, read the instructions, carry it to the fire, release the safety seal and the locking pin, get into position and trigger the discharge towards the fire. Unless the extinguisher is very swift to activate and easy to use, you will find yourself having lost precious seconds. A 30-second delay means you would be trying to fight the fire at this stage. Now, to illustrate the need for speed and power, take a look at this graph. If we catch the fire here, we can only begin fighting it here. And we will need a particular extinguishing power to put it out. While if we catch the fire here, we can only begin fighting it here. And we will need far more extinguishing power to put it out. Now let's just recap our understanding of fire up to this point. 1. Fires grow in intensity as time passes. 2. To effectively fight fire, you need to put in extinguishing power at a rate faster than the rate of growth of fire. Simply put, as time passes, you need exponentially increased extinguishing power. 3. Fire extinguishers therefore need to be lightweight and quick activating, and they need to pack in as much extinguishing power into a compact size as today's technology permits. Fuel, oxygen and heat. Another characteristic of fire is that it can be classified into classes depending on the fuel that's burning. There are 6 different classes of fire, and you need different types of extinguishers to effectively fight the different classes of fire. For instance, fires in solids like wood, cloth and plastics are called Class A fires. Fires in liquids like petrol, paint and chemicals are called Class B fires. Fires in flammable gases like LPG are called Class C fires. Fires involving electrically energized equipment are called Class E fires. Using the wrong type of fire extinguisher could have serious repercussions. In some cases, it can lead to the fire actually spreading. In cases, it can lead to the fire actually spreading. In cases, it can lead to the fire actually spreading. In cases, it can lead to the fire actually spreading. In cases, it can lead to the fire actually spreading. In cases, it can lead to the fire actually spreading. Such as, if a water-based fire extinguisher were used on an oil fire, oil being lighter than water will float on the surface and actually spread the fire. Or it could cause electrocution, as in the case of a water-based extinguisher being used on an electrical fire. Water-based extinguishers work by cooling down the fuel and thus removing heat from the equation. Besides, the water turns to steam on contact with the fire and the steam neutralizes the oxygen in the area. Foam-based extinguishers work by blanketing the flames and cutting off the oxygen supply. Powder-based extinguishers work by interacting chemically with the fuel and altering its properties and inhibiting combustion. In effect, they remove fuel from the equation. Another important aspect is the fact that different types of extinguishers require different methods of use. Foam-based extinguishers need to be applied first to the far edge of the fire. CO2 extinguishers require a more static application to blanket the flame and so on. So not only does one have to judge the type of fire and select the right extinguisher, but one must also have the skill sets to operate each extinguisher.
So, how does one select the appropriate fire extinguisher for a given situation? To help us answer that question, here is Mr. Dasgupta.
Common sense tells us that in the majority of offices, factories and homes around us, the main combustible materials are classes A, explode, speed, power and versatility. Let's now look at the correct ways of measuring power. And by that, we mean both the power of a fire's intensity and firefighting power of extinguishers.
The power and intensity of a fire is not measured by the height of its flames, but rather by precise, scientifically developed international standards. Similarly, the power of a fire extinguisher is not measured by weight, but through exact international standards. In India, we have thus far equated the power of a fire extinguisher with its weight. Hence, all 2 kg extinguishers are deemed equally powerful in fighting fire. This method of measurement is as faulty as measuring a computer by weight. Just as we rate computers on the basis of their processing power or memory capacity, so also we define the power of an extinguisher by certain precise parameters. First, the quality and concentrate of the extinguishant. Second, the delivery mechanism through which the extinguishant is discharged. And finally, the third element that defines the power of a fire extinguisher is the quantity of extinguishant inside. When each of these elements, quality and concentrate of extinguishant, delivery mechanism and quantity of extinguishant are at an optimum, you will get an extinguisher of maximum power. When that happens, weight is entirely irrelevant. You could then have a perfectly configured 5 kg fire extinguisher could be 11 times more powerful than another less optimally configured 5 kg. Imagine what this difference in power will mean during the crisis of an actual fire. Imagine the impact of 11 times more or less firefighting power for someone fighting to put out this blaze. But how do we quantify power, both of the fire and of a fire extinguisher? How are they measured? Let's see a fire extinguisher being used on what looks like a very large fire. And now, the same extinguisher used on another less impressive looking fire. The first fire was a film of diesel in a shallow tray. This fire was attacked at a stage when it had reached its peak and was declining. The second fire was a wood fire which had been burning for some time and was deep into the wood. So even when the surface fire was put out to burn, thus making the fire much more resistant to extinction. To avoid such discrepancies and to arrive at a uniform method of measurement, EN standards have defined a standardized process of testing the firepower of a fire extinguisher. The factor that influences the performance of an extinguisher is controlled. The EN testing process specifies the way in which fuel will be constructed in the case of solids or contained as in the case. Even the size of the wood pieces and the depth of liquid is specified. The tests also specify how the fuel is to be lit and for how long it is to be allowed to burn before the firefighter starts to attack it. There is strictly approved gear for the firefighter. Gloves and helmets are allowed, but heat protective visors are only approved if they are non-reflective. The firefighting process is also strictly regulated. Differing and specific time periods are allowed in power and the letters, the class of fire the extinguisher will fight. So for instance,
which is precisely the reason why at ceasefire we test our extinguishers with fire rating tests. And versatility as well as the correctly pressed into use and expected to perform. A scenario that would challenge even the best engineered equipment. At ceasefire, we build our extinguishers to be utterly reliable, and having built them that way, we make sure that we also maintain them in perfect condition. Clearly, the design and manufacture of an extinguisher by local manufacturers working out of a garage. Rather,
is that the ideal firefighting equipment must have to counter these characteristics. Our trainer will now hand out printed literature on understanding of fire and fire prevention. If you have any questions about any aspect of this module or any of our other training modules, please feel free to speak to our trainer. Thank you.